All right, hi everyone, and welcome to this talk, Enter the Matrix. My name is Brendan Abolivier. I'm a software engineer at Element and also core team member at the Matrix.org Foundation. We'll get more into what those are a bit later in the talk. I'm also a core committer on Synapse, which is the reference matrix implementation, which is what we're going to install later in this talk. And you can see at the bottom of the slide my contact details if you need to reach out to me after the talk. Um, so I've been talking about what in this first minutes of a presentation. I've been talking about matrix observers, and so on. But there's probably people among you who don't know what matrix is. There's something we usually like to do at physical conferences, which is a show of hand on who's already heard about matrix, who's using matrix, who doesn't know matrix but still uses it anyway, and that's kind of gives us an idea of whether we can skip the boring part of the presentation. Obviously, for obvious reasons, we can do that here. So I'm just going to go ahead and explain to you briefly what is Matrix. So Matrix is an open network for secure, decentralized, and real-time communications that can be used for interoperable chats, so between different clients, different servers, sometimes different chat platforms entirely. We'll get a bit more on that later. It can also be used for VoIP, for virtual reality and augmented reality. There's a nice demo that was done at First Time a few years ago about that, and it can also be used for IoT. And this platform has a mission. This network has a mission. It's to create a global, decentralized, encrypted communication network that provides an open platform for real-time communication. Um, and to fulfill that mission, that goal, to work towards that, to work in that mission. That network, which is Matrix, is defined by an open spec, which comes with a bunch of very interesting features. You've got group messaging and one-to-one messaging. You've got end-to-end encryption using a library called OHM that implements the uh, double ratchet, signals double ratchet mechanics. You've got VoIP signaling for WebRTC. You've got push notifications, search, unread counts, content repository for media, files, extra, account data to store basically random user data. And the most important of all, I think, is decentralized conversation history, because in Matrix, no single party owns your conversations. All the conversations are shared over all participants. What that means is if you're in a Matrix room, which is a chat room on Matrix, no, that room doesn't belong to one server, like the server who created it or the server of the admin of the room. It means that the 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 room is kind of a decentralized entity, and all of its history is shared with all of the servers participating in that room. Um, so all of those features are offered in four major APIs. You've got the client server API, the server to server API, which we also call the federation API. You've got the application service API that's used to create bridges or advanced bots. You've got the identity server API as well, which allows you to create servers that can act as address books for email addresses or phone numbers that are associated to accounts, so that you can search someone with their email address, for example. Um, it all fits into that kind of distributed architecture, which you can see here, and to, um, so you can see, for example, the identity servers, which are the one implementing the identity service API, which I was talking about. You've got the application servers, which are bridges to other platforms or more advanced bots or stuff like that. And then you've got basically server and clients, which are the which so each client talk to the servers with the client server API, and each server talk to other server with the federation API or server to server API. So Matrix is very much for now on a client server architecture with federated servers, but we're also working on peer-to-peer matrix so that you remove the need for servers entirely. The client service API, client server API is like all Matrix APIs are just JSON over HTTP, and so sending a message in Matrix is actually very simple. You can do that with just a simple curl command with so you can see here you provide an access token that's provided at login or registration. You just send the content of your message. So that's a text that says hello, and you send that to your server into a room, which is that decentralized entity that I was talking about, and you give it a type. So basically, an event. Well, timeline. The timeline of a room in Matrix is organized by in events which have types and each event is a blob of JSON with a type and content basically, and it returns an event ID. And so what I've shown here is how to send text message, but Matrix can do much more than that. And I mentioned IoT before. So for example, if you wanted to control a UV light, you could send something looking like that. So that kind of event is not mentioned in the spec, is not described in the matrix spec, but it is but it is also something you can send because matrix just accepts arbitrary events that you can define and that and process as you want basically. So that's basically something different, very similar to the previous example, except you're going to have another type, which is so org.matrix.midi, and you're going to give it a very specific content, and it's still going to return the same kind of payload, the same kind of response with an event ID in it. In terms of the other APIs, so they're all very similar in that they're all HTTP, JSON over HTTP or JSON over HTTPS generally. So you've got the server-to-server API that synchronizes messages and room state between servers in real time, and so that also allows them to retrieve history from each other and query a bunch of things from each other. So that's basically the API that allows servers to communicate between each other. You've also got the application services API, which is a kind of privileged version of the client server API, and can so for example they can perpet they can perpet some users. They can create virtual users so that if you're in a room that is, for example, bridged to IRC, you're going to see other IRC people as if they were matrix users. That gives you a bit of a peek into the general matrix ecosystem. Which is pretty wide and very interesting to look into. So when you look at how matrix works in general from in terms of the interactions between clients and servers and how you can build that and what you've got in the whole ecosystem, you've got a bunch of servers. So you can see here. Synapse and Dendrite. So Synapse is the matrix server we're going to install a bit later in this talk, and Dendrite is another kind of a second generation home server for matrix that is still under development, and you've got all the app services and bridges. So that's very much the server side. On the client side, you've got a lot of libraries for Android, for iOS, for JavaScript, So those are the ones the foundation maintains, but you've got a whole lot more on the community side, and you've got a lot of and so you can use that to build the clients. For example, Element, which is kind of the one of the flagship clients for Matrix. But you've got also a whole lot of other clients. You've got Quaternion and Nico in Qt and C++. You've got Fractal, which is under the umbrella of the GNOME project, which is and is written in Rust. You've got Thunderbird currently working on an integration of Matrix into Thunderbird. Gomux, which is a TUI client written in Go, and FluffyChat, which is a very nice looking client written with Flutter. And of course, and so to kind of harmonize all of that, the client side and the server side, you've got the specification. In this case, the client server API. Though in case of application services, it's also the application service API on top of that. Um, so you've got clients available for on every platform, and so you can see that on this by clicking on this on this link. You've got a whole lot of very interesting clients for a lot of platforms, very good looking as well. And if you want to build your own, you can use one of the many SDK. So uh, official. So when I say officially, it's as the Matrix.org Foundation. We maintain four of them: JavaScript one, React one, an iOS one, and an Android one. The community has built a whole lot of other SDKs for other platforms. So you've got one in Go, in Python, Java, Ruby, Rust. You've even got one for the Nintendo 3DS. One of our community member built a client, a Matrix client for the Nintendo 3DS, which works pretty well, and made an SDK out of it. You can find them by going through this link. I'll send the slides through the conference's website, so you can download them and check it out yourself. Um, in terms of home servers, on the other side of the spec, in a way, you've got two official, as in maintained by the community, the Matrix.org Foundation. We've got Synapse, we've got Dendrite, and we've got a few ones maintained by community members. So Conduit, which is written in Rust, Construct in C++, and you've got a few more. In terms of the global status of the community, as of right now, we've got about a bit under 19 million visible accounts on Matrix, sending a bit over 5 million messages per day across over 4 million chat rooms, and they're all distributed over 45,000 servers approximately, and yeah, a lot of bandwidth, and a lot of projects building on Matrix, and also even companies building on Matrix, and governments using that as well. Currently, the French government is deploying a Matrix-based solution, as well as the German government and others that are kind of more in the building in the conception phase. Right, so now that we've gone through that whole chunk of information, let's install a home server. But wait, what's a home server? So that you've heard me use that term a bit before. We're going to explain. I'm going to explain now what it is, what it concretely is. In Matrix, you've got roughly three types of servers. You've got an identity server, which is, as I said, kind of address book of email addresses and phone numbers associated with Matrix accounts. You've got application services, which are bridges and more advanced bots, and you've got home servers. A home server is basically going to be the home of a Matrix account. It's going to implement both the client server API and the federation API, and that means that a client that connects to clients and both clients and servers are going to connect to a home server using their respective APIs to send and receive messages. Also, I just wanted to mic shade a bit here. When I say it's the home of the Matrix account, that's how it currently is. And we're also working on portable identities on Matrix so that your home server, the home server you're sign up with, doesn't have to be the only home server you can use your account on. It doesn't, so that it doesn't have to be the only home of your Matrix account. um, so the home server we're going to implement again is we're going to install is Synapse. It's a reference implementation. It's open source on GitHub under the matrix-org organization, just on the Synapse repo. And the plan will be for us to install Synapse using the official Arch Linux repo, configure Synapse, and also install and configure a reverse proxy at the end of that. So let's do this. So let me switch to my terminal, get that a bit bigger, and let's just start with sudo pacman as matrix synapse. So we're going to install. It's going to install a bunch of dependencies as well, and we're just going to wait for this to finish. Right. So it's finished, and it's done a bunch of, and it's told us a bunch of things. So currently, so the current package on Arch Linux, which by the way is not maintained by us, but by the very nice Arch Linux community, well, the very nice Arch Linux trusted users, and thank you very much for providing that package. So that package doesn't generate a configuration just on the fly. So what it does is tell us that we're going to need to do that. So it first tells us to go to that directory. The slight issue is we can't access it as of right now. So I'm just going to chmod it very temporarily so that we can access it to do what it asks us to do. And so we're going to we're going to first look at what that command is. So on the first line we see that we're using Python. So Synapse didn't really mention it, but Synapse is written in Python using Twisted as its using the Twisted framework for networking, and also a bit of asynchronous, but we're slowly migrating to, and I think we've almost entirely migrated to to the async.io Python core library. And so we're going to use Python to start Synapse, and we're going to give it a few more things. The first one is we're going to tell it to generate the config, because we don't have a configuration yet, so that's what we want to generate it. We're going to give it a config path. We're going to tell it that yes, we're happy to send it usage stats, which are which are completely anonymized. It's just, so the point of that is like, it's not going to your home server is not going to send us, for example, the complete list of members or whatever. It's just going to send us some very broad aggregated statistics so that we can make some decisions when planning the development of Synapse. For example, it's going to tell us your Python version and your database version so that we can know, for example, Python 3.5 got reached its end of life last month, and so we're looking at those graphs to see how much home servers in the wild are using Python 3.5, so that we can decide when we can drop support for it. So that's an example on how we use the stats. and we're going to provide it with a server name. So so in Matrix, all of the everything has an ID. So the user has an ID, a room has an ID, a group has an ID, an event has an ID, and in most of those IDs, you're going to use for different reasons. You're going to use the server name, which is going to be the identifier of your server. So, for example, if my server name is example.com, sorry, it has to be a domain name, a valid domain name. So if my server name is example.com, for example, my user IDs are going to look like at Brandon on example.com. So they're going to look a bit like that. Um, so we're going to, so it has to be a server name, well, it has to be a domain name that you own. Doesn't have to be, we'll see a bit later that it doesn't have to be the name of the domain name where you're hosting your home server. So we're first going to cd into there, and then we're just going to, so I'm just going to open this very quickly, open gedit very quickly to edit that, and we're going to change that into my domain name, the domain name that I've got for this demo, which is archconf2020-demo.ablv.bzh. Um, and we're just going to to run that in our terminal. Tilix is very nicely asking me if I'm happy to run a sudo command. Yes, I am. And let's do this. And we can see, and it's telling us everything it's done, it's been doing. And so the main config file, the one we're going to look into is called homeserver.yaml. So let's have a look here. That's right. So we can see that it's already pre-filled a bunch of things. So the server name was pre-filled from the command line arguments. All of the path and files and all that are pre-filled with the current path where when you're running the command, which is why we feed it into 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 varlib synapse. So we're going to, sorry, I'm getting my notes here so that I don't overlook anything. So the first thing we're going to do and that we're going to talk about uh, is enable registration, which is right here. So by default, registration is disabled on Synapse when you install it. That is basically for moderation purposes. We've got in the past we've seen a lot of spam from big public servers on Matrix, and we've seen people just basically crawling every Matrix server they could see to to see if they had registration open and if they could create an account to spam other rooms. So just so if you're setting up your just a private server for you and your friends or you and your family, you don't need to enable it, or you can just enable it just for the time so everyone can create their accounts. But if you, yeah, my point is really if you want to enable it, just make sure it's actually what you want to do. So we're going to enable it for this demo just so we can test our home server later. We're also going to we're also going to look at the database. Actually, I've got a slide on that. Synapse will use an SQLite database because it's the easiest to set up. And basically the easiest if you just want to set up Synapse and just start it up and see how it goes. We recommend Postgres for production though, for performance concerns. And in the future, we're even going to deprecate SQLite for federation. So that means that won't be that in the future you won't be able to use Federation. Well, you might not be able to use Federation if your server is using SQLite, because we're getting a lot of support requests because and performance issue reports because of people using SQLite. There's some dog here if you needed to set up Postgres. So we're not going to change that right now just because we want a quick and easy config. And I think that's about everything we needed to do. Just a very quick note on the log config. The package that you install provides a file called log underscore config.yaml, which is a bit outdated and not really usable with everyday Synapse. By default, when you run the generate config command, Synapse will automatically generate its own logging configuration. So that's the file in which you configure how you want Synapse to log. By default, it's going to just log in your current directory. Well, in the directory you were when you created that doc, that configuration file. And you can obviously change that and define a lot of stuff. This is a standard Python logging configuration, so feel free to look it up if you want to see a bit more on how to configure it. Right, so last but not least, we're just going to, so first we're going to start Synapse, and it started correctly. It's giving us a bit of a warning, but that's more of a not really advanced, but not something I have time to touch on in this presentation. So Synapse is running. It's running on it's running currently. Let me just go back up here. It's running on one listener right now, which is a localhost listener on port 8008 with just pure HTTP. The reason it's just running on localhost is because Synapse, well, the whole of Matrix now requires TLS for federation, and so up till Matrix 1.0 in June 2019, we were using protocol perspectives to validate TLS in federation, which was a project that allowed you to say allowed the server to say if that many servers trust that server's certificate, I'm also going to trust it. Starting from Matrix 1.0, we now require a valid TLS certificate, and well, a certificate validated by certification authority such as Let's Encrypt, and so you usually want to do that with a reverse proxy. Just as a quick parenthesis here, Synapse does have ACME support, and it actually does have the configuration to provide. If I can find it, yeah, it even has the configuration. Yeah, here it is to serve HTTPS itself with a TLS certificate and a TLS key. However, and it also has built-in ACME support, which is using TLS's TX-ACME library. The issue with that is that that library, as of right now, only supports ACME v1, so the v1 version of the ACME protocol, which is currently being turned off by Let's Encrypt. I think it's only available currently for existing domains on existing accounts. There is some work in progress on Twisted side to support Acme V2, but the progress is slow. Twisted is a non-profit organization powered by volunteers who might not have the time to work on that. So currently we still have our Acme, so Synapse still has Acme support, but we don't recommend using it for new servers because it's not going to work. Instead, we we suggest, we advise using a reverse proxy, which would reverse proxy the local host listener that I showed you before. On this demo, I'm using Caddy because I'm familiar with it, and it's got automatic TLS. So, but other options definitely work. So on here you've got a link to one of our docs on how to use a reverse proxy with Synapse. And you've got a whole lot of examples on how to use it with Apache, HAProxy, Nginx, and so on. So we're going to use Caddy2, and you can see, I'm going to zoom a bit. So you can see that on here that every single config example has two hosts. The reason for that is because we're differentiating the client port on which we're going to expose to clients, which usually is 443, so that clients can just connect to their home servers like any HTTP API. And we've also got the HTTP federation ports, which is by default on 8448, and we'll see a bit later how we can change that. Sorry, wrong terminal. Yeah, let's do this. So on these bugs, I've already installed Caddy, so I'm just going to change the config file, which is currently just hello world. I've already kind of prepared that configuration. For now, we're just going to use the same domain name for both because we're not doing any kind of delegation. And so just that domain and that domain on 8448. And because we've got the doc handy, we can just copy that, and we're going to restart Caddy. Hopefully everything is going good. Yeah, it seems like it. And now if I go to my domain archconf 2020 demo, and I go into matrix, I should have, so right, so now I think the one I'm looking for is, yeah, it's this one. So it works. Synapse is running. So yeah, we've installed Matrix, and we've installed a home server, we've installed Synapse, and we can now use any Matrix client to connect to it. So I was planning to demo that with an actual client, but I'm kind of running out of time. So let's see very quickly what we can do to go a bit further in our setup. So Synapse has something it calls workers that allows big servers to scale horizontally. The reason behind that architecture is that Synapse is written in Python, and therefore, very roughly, one process equals one CPU core. That's sometimes the result of that is that sometimes Synapse gets CPU bound, and is a bit starving in terms of CPU, and so workers are going to be just different processes that use different CPU core, and that's going to handle part of the main process's workload. and you do the and so they're communicating between each other through Redis, and each request is being routed by reverse proxy, basically. A good example on the usefulness of workers is syncing. So in Matrix, a client receives messages by syncing. So it's well, what we call syncing is a long poll on an endpoint called /sync, um, and um, and so that's how it's going to get new messages, new data, new invites, new rooms, and all that. And that process can be a bit heavy because it's dealing with a lot of events and potentially a lot of users. So it's kind of the perfect example of something you can just offload to another process with workers and well synchrotrons as we call it as we call them. Another completely different nice thing about that you could do with your server is using delegation. So that would allow, for example, example.com to be hosted at matrix.example.com. What I mean by that is that the actual synapse is hosted at example.com, but the server name you give it is example.com. Because it's something I kind of forgot to mention, like why the server name needs to be a valid DNS name. It's because it's because well, the other servers are going to use that name to try to reach your home server. Delegation can also allow the federation port to be something else than the default one. So for example, so the default one, as I mentioned, is 8448, but you could change it to be 443 and basically have both client API and federation API on the same port, which might be easy in terms of routing and whatnot. There are a couple of methods to do that. The most recommended one is just setting up a JSON file at a well-known URI on the delegating domain. So in our example, the delegating domain would be example.com. So an example of that is that on example.com /well-known /matrix /server, you've got that JSON file that's being served with m.server, which contains the address, the hostname and port of the home server. So that would allow home servers federating with example.com to send their traffic through matrix.example.com on port 443 instead of example.com on port 8448. A couple other features that you might want to look into. You've got turn. So setting up a turn server is well, turn/turn server is what is something that could be very useful if you want to do void behind the NAT. And we've got some kind of and Synapse somewhat supports turn servers in that you can give it a turn server that it can then provide to clients. And another useful thing to have is metrics and monitoring on your Synapse. With Prometheus and Grafana, you've got a whole lot of info here, and we also provide the JSON for a Grafana dashboard that you can use. And that's it for me. Thank you for listening to me rambling about Matrix and servers. And if you've got questions, I should be there in the Q&A. Thank you very much.